Throughout history, humanity has pondered one of its oldest questions. Are we alone in the universe? Given the vastness of our cosmos, it seems improbable that we are the sole inhabitants. The 19th century saw a shift towards a more specific query. How prevalent is life in the universe? Could it have emerged multiple times within our solar system? Perhaps even on Mars, the planet most akin to our own? Speculation soared, with science fiction envisioning entire civilizations on the red planet. However, as our probes and satellites unveiled only desolate landscapes, the fervor subsided. Yet the question persisted, evolving to ponder whether life once thrived on Mars in its ancient past. Despite decades of exploration, the answer remains elusive, lingering in the realm of possibility. The discovery of past liquid water on Mars in the 1970s was groundbreaking but inconclusive. If confirmed, it would revolutionize our understanding of the universe, suggesting life could have arisen beyond Earth. However, until we unearth the first fossilized evidence of extraterrestrial life, uncertainty prevails. In pursuit of certainty, NASA embarked on a mission with the Perseverance rover. This video chronicles its inaugural campaign, tasked with collecting samples of fossilized microbial life on Mars. Could this rover finally resolve the age-old question of our cosmic solitude? The journey commenced on July 30th, 2020, as Perseverance embarked on an Atlas V rocket amidst an opportune alignment of Earth and Mars. After a 7-month voyage, the rover braved the perilous descent onto the Martian surface. With precision and ingenuity, NASA orchestrated a complex landing sequence, culminating in Perseverance's touchdown on February 18, 2021. Perseverance, the most advanced rover to date, inherits the legacy of its predecessor, Curiosity, yet boasts significant enhancements. Thicker, more durable wheels and a robust robotic arm equipped with advanced scientific instruments mark notable improvements. Unlike Curiosity, Perseverance's primary objective is to seek tangible evidence of past life on Mars. Armed with sophisticated cameras and spectrometers, Perseverance scans the Martian terrain for compelling rocks, analyzing their composition from a distance before approaching for closer examination. Once identified, the rover employs a drill to extract samples, meticulously preserved for return to Earth. To ensure scientific integrity, Perseverance employs witness tubes to capture ambient contaminants, safeguarding the integrity of collected samples. These meticulous precautions underscore the significance of this mission, which promises to redefine our understanding of life's place in the universe. Regrettably, Perseverance alone cannot validate the existence of microbial life. It serves as a precursor mission, intended to gather and cache samples for a future mission's return to Earth. NASA envisions a sample return mission scheduled for 2026, utilizing a rover to retrieve the cached samples and transfer them to a rocket. This rocket will rendezvous with an orbiter for the journey back to Earth, with the samples anticipated to arrive in 2028. However, finalizing the means of collecting these samples remains a challenge, requiring meticulous planning and execution by the mission teams in the years ahead. Upon activating its cameras and surveying its surroundings, Perseverance beheld the familiar red, desolate landscape of Mars. Positioned strategically within Jezero crater, the rover's surroundings featured predominantly flat terrain interspersed with rocky outcrops, a deliberate choice by scientists. This selection facilitated Perseverance's mobility and access to scientifically significant sites, leveraging the geological diversity surrounding the crater to unravel its history. To pinpoint potential life-bearing sites, Perseverance embarked on 2 distinct campaigns: the Crater Floor Campaign and the Delta Front Campaign. These campaigns involved meticulous exploration of various sections within Jezero crater, starting from the landing site and progressing towards the crater's delta. Despite the immediate accessibility of intriguing rock outcrops, Perseverance's departure from its landing site was delayed by nearly 5 months. This delay was not solely attributed to rigorous equipment testing, but also to an unexpected responsibility: Perseverance's unique pregnancy. Concealed within its undercarriage, shielded from the Martian elements, Perseverance carried a smaller companion, Ingenuity. Serving as a technological demonstration, Ingenuity was the first attempt at a helicopter on Mars. Its successful deployment required meticulous preparation, culminating in its historic first flight on April 19th, autonomously soaring to an altitude of 3 meters and remaining airborne for 39.1 seconds. Meanwhile, Perseverance conducted essential tests on its equipment and explored its surroundings. Equipped with a microphone, the rover captured the first audio samples of Martian winds, offering a glimpse into the planet's atmospheric dynamics. Additionally, Perseverance tested its mobility, captured panoramic views, and even extracted oxygen from the Martian atmosphere using the MOXIE instrument. Despite these achievements, Perseverance's primary mission remained unchanged: the search for evidence of past life on Mars. Strategically plotting its route, scientists navigated Perseverance towards potential sites of interest, prioritizing efficiency to maximize scientific exploration within the rover's operational timeframe. As Perseverance embarked on its mission, traversing the Martian terrain towards its designated targets, anticipation mounted for the discoveries awaiting within Jezero Crater. With each carefully selected sample, the rover aimed to unravel Mars's enigmatic past, shedding light on the possibility of ancient life and the evolution of the red planet. The rugged, rocky terrain of Mars presents numerous challenges for a rover like Perseverance. Navigating around scattered rocks and avoiding soft terrain is essential to prevent mishaps similar to Spirit's unfortunate demise in a Martian sand dune. Perseverance's path selection involves a delicate balance, avoiding excessively rocky or soft areas to ensure smooth traversal. In the past, such decisions incurred significant delays due to the Earth-Mars signal delay averaging 20 minutes, hindering real-time control. However, Perseverance benefits from an upgrade compared to its predecessors, Spirit and Opportunity. Equipped with advanced AI software called AutoNav, Perseverance can autonomously analyze its surroundings and determine the optimal path, significantly reducing reliance on Earth-based commands and enabling faster progress. This enhanced autonomy allows Perseverance to conduct more efficient scientific exploration. On July 20th, Perseverance successfully reached the cratered floor, fractured rough terrain, marking a significant milestone. Scientists selected a rock, named Guillaume, for initial testing of Perseverance's abrading drill systems, achieving a simple yet successful outcome. Subsequently, on August 6th, Perseverance attempted its first core sample extraction from a rock dubbed Rubion, capturing a historic moment witnessed by a multitude of engineers and scientists online. However, the elation was short-lived when it was discovered that the sealed tube containing the core sample was empty. Investigation revealed that the crumbly nature of the Rubion rock caused it to disintegrate upon drilling, rendering the sample collection futile. Despite this setback, NASA remained determined to proceed, reasoning that other rocks on Mars might yield better results. Perseverance's second attempt, targeting a sturdier rock formation named Citadel, proved successful on September 1st, with the rover extracting a 6-centimeter core sample dubbed Montaigne. This triumph was followed by further successful core extractions from the rock named Rochette, demonstrating the rover's resilience and adaptability in the face of challenges. The mission encountered a temporary pause due to solar conjunction, during which communication between Mars and Earth became impossible. However, upon resumption in November 2021, Perseverance embarked on its next objective, exploring the dune field known as Sitar within Jezero Crater. Ingenuity, the rover's aerial companion, conducted reconnaissance flights to identify safe routes, enabling Perseverance to navigate the treacherous terrain and obtain valuable samples from the outcroppings of Sitar. Despite the hurdles encountered along the way, Perseverance's mission persisted, driven by the pursuit of scientific discovery. Each successful sample collection brought scientists closer to unraveling the mysteries of Mars' geological history and the potential existence of past life on the red planet. Instead, Perseverance made a surprising discovery: igneous rock, specifically olivine. Unlike sedimentary rocks formed from accumulated particles over time, igneous rocks like olivine originate from the cooling of magma. This suggests past volcanic activity in Jezero Crater, potentially enriching the area with minerals conducive to life. Although volcanic activity might seem initially discouraging for life, signs of water erosion on the rocks indicate subsequent water presence, particularly evident in the delta formations. The coexistence of water and igneous rocks could create favorable conditions for life, as seen in fertile areas around volcanoes on Earth. Despite initial progress, Mars presented Perseverance with another challenge during its return journey from Saturn. Attempting to collect a sample from an outcropping known as Isol, specifically from a stone called rubion, Perseverance encountered unexpected resistance when trying to store the sample. Subsequent examination revealed small pebbles obstructing the sample tube, potentially jeopardizing the entire mission. To address the issue, Perseverance engaged in a series of careful maneuvers. It documented the ground beneath it to track the number of pebbles, then emptied the sample tube to assess the remaining contents. By rotating its carousel, Perseverance dislodged 2 of the 4 pebbles but struggled to remove the remaining 2. Eventually, it drove to a steeper slope, causing the rocks to fall out. This episode underscored the meticulous approach required for handling unexpected challenges on Mars. Despite setbacks, Perseverance's mission persisted, exemplifying the importance of cautious decision-making and problem-solving to ensure mission success. Subsequently, Perseverance continued its journey, setting records for rover speed and completing the first multi-day drive on Mars autonomously. Its advanced capabilities, including autonomous navigation and a heat ray for analyzing rock composition, demonstrate its remarkable scientific potential and ability to operate independently, advancing our understanding of Mars' geological and potentially habitable history. By heating rocks to extreme temperatures, Perseverance can analyze the light they emit to determine their chemical composition. Each element and compound emits light at specific wavelengths, aiding in on-site scientific analysis. This process occurs on a minuscule scale. For example, on March 11, 2022, Perseverance repeatedly targeted a fascinating purple-colored rock with its laser, vaporizing its outer layers for analysis. However, each vaporization only penetrated a single millimeter into the rock, far from being a weapon. These are the tools Perseverance employs as it continues its journey, conducting on-the-go scientific analyses in collaboration with scientists. During its journey, Perseverance inadvertently collected a small rock in one of its wheels. This pet rock has accompanied Perseverance for over 8.5 kilometers, proving less disruptive than previous unexpected acquisitions. However, as one companion arrived, another departed. On May 3, 2022, Perseverance lost communication with Ingenuity, the helicopter that had assisted it since their arrival on Mars. Initially, scientists feared technical failure, but it turned out that Ingenuity had entered a low-power mode due to reduced sunlight exposure, conserving energy to survive the cold Martian nights. Despite this setback, both Perseverance and Ingenuity continued their journey toward the Azeroth's delta. As they approached their destination, the Jezero crater's sands behind them, Perseverance and Ingenuity faced new challenges. Although they had accomplished much in their time on Mars, the question of whether they had found evidence of past life remained unanswered. Only when the collected samples return to Earth will we have a definitive answer. Until then, Perseverance will continue its mission, remaining true to its namesake. Thank you for watching. If you enjoyed this rover story, give it a thumbs up, and don't forget to subscribe. See you next time.